So in this video we studied divisibility. Now I'll give you any number and I'll ask you which of this number are divisible by 2, 3, 4, 5, 8 and then 9. You'll say it's simple. If the last digit is divisible by 2, then the number is divisible by 2. For 4, if the last two digits are divisible by 4, then the number is divisible by 4. For 8, you will say if the last three digits are divisible by 8, then the number is divisible by 8. And that's how simple it goes. For 3, you add the individual digits, get the sum of it. And if the sum is divisible by 3, then you say that the digit is divisible by 3. You take a digital sum of digits and then you think of 3. The same logic goes for 9. You add all the individual digits and you see if the sum is divisible by 9, then that number itself is also divisible by 9. And that's how simple it goes for 9 as well. And let's take the last digit here, which is 5. You just see the unit digit for that. If the unit digit is 5 or 0, then you say that the number is divisible by 5. So to generalize this, if I give you any random big number and if I ask you if this is divisible by 2, you will say just check the last digit. For 4, check the last two digits. For 8, check the last three digits. For 3, you take the digital sum. You take the sum of individual digits. And then you see if that sum is divisible by 3, then the number is divisible by 3. And if the sum is divisible by 9, then the number is divisible by 9. Now, I'm not asking you what is the divisibility test. I'm asking you why does this thing happen? Why is the divisibility test for 2 is the unit digit? Why is the divisibility test for 4 last two digits, 8 last three digits, digital sum for 3 and digital sum for 9? What is the reason for that? Is there a pattern in it? So think about it and post your answer in the comment section. Now let's decode the logic of divisibility. I gave you the number and I asked you which of this number is divisible by the following numbers. So let's take first number, which is 134. Unit digit 4, tens digit 3, hundreds digit 1. What is the meaning of this? There are 4 ones, unit. There are 4 ones in this, 3 tens in this, that's why tens digit, and 100 in 134. So if I add individually 100, which is 100, 3 tens, which is 30, 1 4, which is 4, 134. That's how I get the sum. So divide this entire thing by 2 now to check the divisibility for 2. If you can see 10 divided by 2 and 100 divided by 2, the remainder is 0, which means what? Tens part and the 100 part is always divisible by 2. And the only thing I have to check it here is the unit digit divisible by 2. And if the unit digit is divisible by 2, I say that the number is divisible by 2. And that's how simple it is. For 4, if you can check, only 100 is divisible by 4. Not your 10, not your 1. So I have to check the last two digits, the unit and the tens part. If they are divisible by 4, then I say, if the last two digits are divisible by 4, then the number is divisible by 4. 8. If you can check, neither the 100 nor the 10 and obviously not the 1 is divisible by 8. So I have to check all the three part, unit, tens and then 100, the last three digits, to check if the number is divisible by 8. If you go for 5, if you can see 100 as well as 10 is divisible by 5. So the only thing I am left, just like 2, is the unit digit. I check if the unit digit is divisible by 5, then I'll say that the number is divisible by 5. And now if I go for 3, check 100 divided by 3, the remainder is 1. 10 divided by 3, the remainder is 1. 1 divided by 3, obviously it is 1. So what am I left with? 1 into the remainder of 1. Then 3 into the remainder of 1. Again plus 4 into the unit 1. So if I add all of them, I get the individual sum of digits because the remainder is always 1. So 1 plus 3 plus 4, which is coming out to be 8. Now I have to check if this individual sum is divisible by 3, then I'll say that the number is divisible by 3. And that's why the logic for 3 is digital sum. Similarly for 9, just like 3, the remainder in all this case is 1. 100 divided by 9, 10 divided by 9, the remainder is 1. So just like 3, I'll do 1 into the remainder of 1 plus 3 into the remainder of 1 plus 4 into the remainder of 1, which comes out to be what? 1 plus 3 plus 4, again the digital sum. And if this individual sum I have to check is divisible by 9, then the number is divisible by 9. And that's how simple is the logic of divisibility.